particularly on the manufacturing side. So if you see here, we are talking about multiple technologies, and you can see that many of the new technologies, including battery technologies, as well as some of the other technologies, we are looking at significant gap in terms of the manufacturing ability to meet the net zero target. The other thing which is a very important parameter is also which has been highlighted with some of the supply demand imbalances coming up during COVID, is the dependence on maybe single country or single region for this production, particularly China, because China ended up becoming sort of a global manufacturing hub over the last 20 years. And right now, if you see right from solar modules to batteries to solar cells or cathode material, we are looking at almost 70 to 90-95% of the global manufacturing capacity being concentrated in China. And that's something which I think is needs to be changed. I think China will continue to play a critical role and will be critical partner for many countries. But I think we cannot have a single dependency on the supply chain for such critical transition technologies. And the good part is both US and Europe are pushing in policies for diversifying their supply mix. And that's where there is a window of opportunity for India, that not only for the domestic consumption, but India can develop a robust supply chain and become a sort of a part of the supply mix in the China plus one desire, which many of the international countries are showing right now. But we have a long way to go for that. And one critical aspect for that is going to be that how do we develop the domestic demand and domestic market? Because many times we start seeing, as soon as we talk about manufacturing, we start talking about export. But I very strongly believe that the first thing what India need to do in next 5 to 10 years is to make sure that we develop a robust domestic market and start meeting this requirement. The good part is India is on a one of the most aggressive paths for renewable power deployment with both solar and wind, particularly solar, where we are looking at not just the current 200 gigawatt target, which was for 2022, but we are looking at continuing and getting to almost 400 plus gigawatt of non-fossil fuel energy generation, particularly solar and wind, to be deployed by 2030. And although many times we keep on looking at these solar tenders and say, oh, solar is becoming very cheap. Now solar has crossed the threshold of 2 rupees. So we should just keep on deploying more and more solar. But we are now seeing that some of the 6, 7 sort of a renewable rich states, we are starting to get to a stage where the projected deployment for solar for 2030 is almost 2 to 3 times the demand for the state. So that's going to create very significant imbalances in terms of the investment required for the transmission and evacuation capacity. And if you're building all that transmission evacuation capacity just for solar, that means that it's going to have a utilization factor of somewhere between 10 to maybe 12, 13, or maybe 15% at the maximum. So it is very important that we start looking at wind, solar, hybrids, as well as additional storage to be there, so that you don't end up depending on thermal power for filling in all this gap between the renewables and especially the late afternoon and evening peaks, which are most common with most of the states. Because if we start doing it, and right now with existing stranded capacity, it may feel that the thermal power is a best suitable energy for this. But if you start looking at real economics, where if you start building thermal plants, especially considering the load growth, what we are expecting in the coming decade, and start building thermal power plants with as peaker plants, then the cost is not at all going to be cheaper. We have existing long-term coal contracts with 3 rupees or 3.5 rupees, and it may seem that that's cheaper than doing renewables plus storage. But if you start thinking about these similar projects which you have to build now with a assumption of 30-40% CUF versus almost 80% CUF, which was almost assumed for all the existing coal plants which is built up, then suddenly you are going to start seeing 7 rupee to 10 rupee as a levelized cost requirement for making this thermal plant sustainable. And renewables plus storage is already has breached that range. So if you think about say solar plus storage. Already, depending on if you're doing it for 1 hour or 4 hour, in 2023, you're looking at price points between 5 rupees to 9 rupees per kilowatt hour as a incremental cost. And if you think of it as a firm renewable power, where as a entire RE plus storage you are paying the same tariff, then those prices are somewhere around 4 to 5 rupees right now. And by end of this decade, we expect these prices will come down below 3 rupees or somewhere between 3 to 4 rupees. So I think we are already reaching a stage where RE plus storage is very clearly poised for replacing peakers. We are already seeing this happening in developed countries. And within this coming decade, we expect that RE plus storage will also replace intermediate plants. So we still need maybe some thermal plants, some hydro plants, some nuclear plants as a baseload unit, as a 24 by 7. But many times we start talking about round the clock renewables, which I think at least for next 15 years is not a necessity. What we need is we need a flexible and dispatchable renewable power, and that can be achieved with 4 to 6 hours of storage or maybe up to 10 hours of storage. And many long duration energy storage technologies are expected to also get commercialized by 2030 to 35, which can help us get to 10 hour firming of renewables. Now, one of the critical aspects for making this possible is policy. I think policies make a very critical role for giving a signal for the industry to invest into technologies as well as investing into manufacturing. And the good part is since 2013, we have seen a steady progress in the same direction. Sometimes we do have some challenges where we take 2 steps forward, 1 step back. But the good part is, especially since 2015-16, with the Prime Minister Modi's vision, we have been actually taking maybe 3 steps, 4 steps forward, 1 step backward. So the pace of progress is definitely fastening. And I was fortunate to get a chance to meet with the Prime Minister a few times, and the kind of clarity what he has in terms of use of renewable energy and also making India a manufacturing hub is amazing, and it is starting to trickle down into the various levels of bureaucracy now, where now we see many activities, including the especially the PLI missions, various large scale tenders from SECI and other agencies are starting to come up, as well as now various states have started to get very actively involved, particularly for EV deployment as well as for manufacturing. And we are seeing around 6 to 8 states are very actively competing with each other, making a better business environment for industries to invest into. In terms of overall energy storage requirement for stationary applications, we have been releasing this report since 2013, where our last year's report talked about requirement of almost 400 gigawatt hour of storage across technologies. So these may include some pumped hydro facilities, some lead acid batteries for backup, as well as lithium ion and other emerging technologies for other applications. Our base case suggests that almost 60 to 70% of the deployment of these technologies will be on the customer side, and then around 30% on the grid side. But we have also worked with Ministry of Power and CEA on coming up with a national energy storage target, and that suggests that we may have a requirement of at least 160 gigawatt hour for supporting the 500 gigawatt renewable target, which is given by Prime Minister for to all. This is something where we are still waiting for concrete numbers, because one thing what we have found out very critical is that the national storage mission with a target of 200 gigawatt for solar definitely helped in moving the industry forward, where we have seen the prices coming down from almost 17 rupees now to 2 rupees, 3 rupees per kilowatt hour for solar energy. But that also happened because we just didn't have an end year target, but there were very clearly year by year tenders and scale up of the industry activity, which was envisaged. And that's exactly what we need right now for storage, where we don't need just a number for 2030 or 2035, but we need to start deploying storage for the right applications every year and start building the industry capacity for not just manufacturing, but also for deployment, operation, and learning. The good part is we are now seeing tens of projects happening on a distributed format, unlike many of the developed countries where for many years the storage deployment was focused on just couple of states. Like if you take example of US, majority of the storage deployments took place in the territory of PJM as a market in Mid-Atlantic region or in California with very strong support from California Energy Commission for various pilots. But in India, we are seeing that there are more than a dozen states where there are projects being deployed, not just at a less than 5 megawatt scale, but even for greater than 5 megawatt scale. And we are also seeing that these tenders are no longer just dependent on tenders from SECI, but many other state agencies as well as other PSUs such as NTPC and others have also started to come up with tenders for anywhere from 10, 20 megawatt to even going up to 500 megawatt or bigger scale at a single project. So we are definitely starting to now catch attention of companies around the world. It's very important that we now follow up and deploy these projects in a timely fashion, because one biggest challenge for India over last 5 years has been not the shortage of announcement, but actually the shortage of closure of the projects and deployment. But now I am fairly confident that most of these projects which are announced will go forward. This year in the budget, government has also announced special viability gap funding for the first 4 gigawatt hour of energy storage project deployment. So many of these projects will be able to take benefit of that as well for increasing the viability and moving forward faster. Now, switching gears and coming to e-mobility, again, many times internationally, when you talk about e-mobility, people end up focusing just on four-wheelers. But when it comes to e-mobility transition in India, it is much more diversified. Especially the e-mobility transition started with electric three-wheelers, with e-rickshaws, even using just lead-acid batteries and importing kits from China to start with sort of a low-speed e-mobility. But now in last 2 years, with the FAME 2 incentive, we have also seen tremendous growth with electric two-wheelers, particularly performance electric vehicles, which are more than 70 kilometers per hour as our top speed. And we are also starting to see now commercial vehicles such as buses being promoted through various state procurements, as well as now electric cars with especially Tata Motors stepping up its activity. We are seeing a very strong response from customers. Still just 3-4 years back, I think most of the EV companies like Mahindra's were like lucky to sell 1,000 vehicles in a year, whereas just recently Tata Motors has announced they have now crossed landmark 50,000 electric vehicle sales, and they are expecting to start getting to hundreds of thousands of sales each year starting this year onwards. Um, in terms of the CAGR for the EV trend, if you see, it is growing almost at within last 2 years has grown more than 200%. In terms of the number of vehicles, we have also crossed the million registered electric vehicle as a landmark. And again, this has mainly changed within last 2 years. So we have gone almost from 100,000 vehicles to more than million vehicles within a span of 2.5 years. And right now, in terms of the number of vehicles, it is clearly dominated by two-wheelers and three-wheelers. But if you start seeing the emergence of a lot more options coming to electric cars, we think that the other segments will also start seeing the growth. One key change which has happened is that there was this perception amongst auto OEMs that in India, customers are only trying to buy vehicles which are sub 9 lakh rupees. And that's where, unfortunately, with some wrong strategic analysis, they ended up focusing on trying to bring to market electric vehicles which only had a driving range of 80 to 100 kilometers. Whereas all the economic analysis and the customer feedback showed that the customers who had most to gain by switching to electric vehicles were the customers who were driving more than 200 kilometers per day. So for them, it was just a question of financing an electric vehicle. So the capex was not as much important as what was required was having the right driving range and having the right charging infrastructure. And as soon as companies like Tata Motors introduce vehicles like Tigor and especially Nexon, we have started seeing this shift where customers are able to finance vehicles. We have now individual companies like Blue Smart investing in fleet of more than 10,000 vehicles as a single entity. A few years back, we were looking at just the 10,000 vehicles to be procured as aggregation by ESL. Now, individual companies are looking at procuring 10,000 or more vehicles. And we do expect this trend is going to continue. And we are expecting by 2030, we will cross almost 50 million vehicle sales. If you think about batteries for vehicles, then the market is much more balanced with almost 30% going to two-wheelers, 30% going to three-wheelers, and rest divided between four-wheelers and cars. Now, coming to the last part of my lecture, I think, as I said, that we decided back in 2015-16 that India cannot just focus on deployment, but India need to also start looking at manufacturing. And that's where in 2016, we had set a vision of getting 20 gigawatt hour manufacturing in India by 2020. Unfortunately, we could not convince all the policymakers at that time. It took us almost 3-4 years to get through all the right policies in place. But in 2018, we were invited to be part of a global expert panel to advise Indian government on solar and storage manufacturing. And since then, we have seen a rapid change where the entire PLI schemes were introduced based on the recommendations which are provided to government. The battery PLI was one of the first PLIs which was designed, but then with COVID, it was decided to expand the production link incentive scheme to more than 15 sectors. As a result, it took some little bit more time. But finally, in 2020, the scheme was released. In 2021, the tendering process began. And then last year, 50 gigawatt hour of ACC PLI capacity was awarded by Department of Heavy Industries and Niti Aayog. And now this year, we are expecting additional 25 to 50 gigawatt hour of PLI to come in to support stationary storage, as well as additional 5 gigawatt hour niche SEC program for next generation technologies. Now, most of this manufacturing will take almost 18 months to 2 years to get commissioned. So again, they don't expect suddenly domestic manufacturing to hit market next year, but we do expect by end of 24 or early 25, we should have at least 20-25 gigawatt hour of domestic manufacturing. That's where in September 21, on occasion of World Energy Storage Day, we set a vision that we don't want to be just focusing on the 50 gigawatt hour government supported program, but as an industry, we should be looking at getting to at least 100 to 140 gigawatt hour of manufacturing capacity by 2030, and then continue to build in to get to 500 to 550 gigawatt hour domestic manufacturing by 2035. And while doing that, we are also trying to set a very clear vision that we want to start looking at sustainability of the manufacturing, looking at using 100% green energy, as well as making sure we are addressing the sustainability of the supply chain as well as in this process. We are happy to say that right now, apart from the 3 companies who have got award from government, there are at least 7 to 8 additional companies who are in process of setting up gigafactories in India. And we are seeing again 5 or 6 states emerging as a potential hubs for this manufacturing and associated supply chain. There is a tremendous opportunity and need for almost more than 10 to 15x growth in the development of the supply chain for supporting this manufacturing. Indian government has very clearly set a target of at least 60% domestic value addition, but based on the feedback what we are getting, we do think that we have the opportunity to do a lot of especially midstream processing of various chemicals in India, and that can create a huge job opportunity in India as well as export opportunity for supporting gigafactory manufacturing in Europe and US. So 2 years back, we set up this India Battery Manufacturing and Supply Chain Council, where we started with just around 7, 8 companies to start with, but now we have more than 30 companies who are very actively investing into everything from doing raw material processing to working on cathode active material, anode material, separator, electrolyte, and other components of required for manufacturing, including copper and aluminum foil in India. So we are very confident that within next 2 to 3 years, we should be in a position to localize 60 to 70% of the value addition in India with this support. We are also happy that agencies like United Nations Industrial Development Organization is supporting energy storage industry through facility for low carbon technology development deployment, where already last year 7 companies got initial funding of $50,000 each for doing beta deployment, and now we are in process of second batch of additional 10 companies are expected to get the funding within next couple of months. They are going through final due diligence from the UNIDO expert panel. We need to scale up these type of support for commercialization of technologies, and that's where again I look forward to working closely with IEEE to looking at how we can work together for accelerating technology commercialization in India. The major challenge which is going to be with considering the pace of change and the global competition for talent is the skill development. There are many new and interdisciplinary skills which are going to be required. So that's where as IESA we are working with IEEE, with other organizations working on policy, automotive side, material side, and try to bring together cross industry expertise to the fore. We are also working with more than a dozen industry academic partnerships through various members, including VZTI, Pune University, IIT Madras, MIT Pune, and others, as well as international organizations like Carnegie Mellon and Stanford University. As I mentioned, we are in process of launching scholarships with IEEE. We have also announced earlier this year 10 fellowships for postdoctoral researchers to do 1 year of industry-led research in part collaboration with Department of Science and Technology. I'm happy to say that we received more than 75 applications for these 10 fellowships, and we are in process of finalizing this initial batch of 10 fellows who will work on industry-led research as a 1 year postdoctoral fellows in next month at IESA's annual conference, India Energy Storage Week. We have also launched a virtual platform, IESA Academy, through which we have already been doing series of webinars for IEEE students, but there are also additional professional training programs because we are also seeing very strong interest from mid-career or even senior career professionals who feel that they have associated skills, but they haven't really worked in the industry. So they can be part of many of these professional training programs and help in switching their career to energy storage, e-mobility, and associated industries. One thing which is very important is safety, and this is the part where IESA has formed a strong partnership with Underwriters Laboratories and bringing focus on safety and standards. And this is the area where I urge everyone that please don't take as Dr. Tagare used to say, chalega, nahi chalega. We are going to need to focus on quality and safety because the biggest risk we have right now for industry is these type of fires, which can actually slow down the customer confidence. The other area which is related is green hydrogen, where again India is taking a very strong leadership, but there is some confusion where some people think that hydrogen is competing with electrochemical storage technologies, whereas the way we see it is that in India, it is very clear that the major application of green hydrogen is going to be for industrial decarbonization for areas like refining or fertilizers, where just electrical energy storage is not going to make the inroad. So there is more complementarity, and for green hydrogen to make a reality, you actually need renewable energy plus energy storage as a hybrids, so that you can start using electrolyzers with 60-70% utilization and bring down the levelized cost of green hydrogen, rather than just investing in electrolyzers and using them 20 to 25% capacity utilization factor directly connected with just RE power. We do see as the green hydrogen prices come down, there will be other grid applications and automotive application which may also come in. But right now, at least almost 90 to 95% of the applications for next 5 years are expected to be for industrial decarbonization. The good part is India already has more than 6 million metric ton demand, which is a 10% of the global demand for hydrogen, which is currently supplied through steam methane reformation. So mainly we are looking at starting to blend green and gray hydrogen and start moving towards 25% green hydrogen. Prime Minister Modi personally is taking a lead in this push. Last year, he announced focus on green hydrogen as part of the India's clean energy mission. And earlier this year, the green hydrogen mission is also announced with allocation of almost 20,000 crore rupees, similar to the 18,000 crore which was allocated for battery industry. And as part of that, with also Department of Science and Technology, there are 3 to 4 hydrogen valley projects which are being expected to get developed within next 12 months. And I'm happy to say that with the strong presence of R&D institutions like NCL in Pune, Pune is a front runner for hosting one of the Hydrogen Valley projects. So again, there will be a competition, so it's not given, but as IESA, we are working closely with NCL and Pune Knowledge Cluster to improve chances of Pune being one of the 3 to 4 hydrogen valleys set up in India. So anyway, I think I've gone a little bit longer than what I had intended, but if you need more information, please do feel free to visit IESA website, download various knowledge papers. There is also a website called etn.news for emerging technology news, which covers latest information from around the globe related to the sector. You can download our podcast on all the podcasting services to stay engaged with the industry and listening to other experts. Also, I would urge all of you to, if your schedule permits, do join us for India Energy Storage Week 2023 in Delhi, where we have a 5-day program. First day technical workshops, second day on stationary energy storage, third day on manufacturing and R&D, fourth day on e-mobility, and fifth and final day on green hydrogen. And happy to say that IEEE PES is one of the supporting partners for this program. So again, if you need any information, feel free to ping me directly. Also, please block your calendar for 22nd September, which is a World Energy Storage Day, where again IESA hosts a free conference, virtual conference, featuring more than 150 global speakers, where it's a non-stop 24-hour marathon event where on a single day you can learn about all the developments related to storage, e-mobility, green hydrogen, and manufacturing on a single platform from Australia going all the way to US on a single day, covering world into 4 regions. So anyway, with this, I would like to end my presentation. And again, if there are any questions, happy to answer those. Thank you.
Thank you, Rahul sir, for your very informative lecture. I request all participants, if they have any questions, they please put it in chat mode so that we can ask to the expert. Rahul sir, meantime, we have some couple of questions in chat window. Shall we go ahead?
Sure.
Okay. We got the first question is, I think so, round trip efficiency, how it is related to cost. This is a question in the chat window.
Sure. So again, that's a very good question. When we come to efficiency, there are different efficiencies mentioned as a Coulombic efficiency, DC efficiency, or round trip efficiency. Typically, when we look at the economics of storage, we like to focus on round trip efficiency, which basically means that how much energy you are getting out from the storage device as compared to the total amount of energy what you are storing into the storage device. So that makes it very clear because that is mainly related to the operating cost. For example, if you are storing, say, energy in a device with 100% efficiency, then if you are storing it at 2 rupees, anytime you have a price more than 2 rupees, you will be able to recover that energy. Plus, maybe you need to add some additional cost for recovering your capex investment. But if you have a storage technology which is 50% efficient, and you are storing energy at, say, at night as a landed cost, including distribution and other costs, with say around 3 or 4 rupees, then for making any money just on the energy cost, you will need to get a difference of more than 2.5 rupees to just recover the losses in the device, right? So that's where, particularly when you start looking at energy applications where you're looking for longer energy throughput, I think people are looking for now technologies which have at least 70 to 75% round trip efficiency. Otherwise, doing storage projects for 4 hours or longer duration does not make sense. On the other hand side, if you're looking for storage as mainly seasonal storage, or where you're looking at it more as a capacity resource where you are not expecting storage to be discharged every day, then maybe you'll be more interested in the standby efficiency or the standby losses. And it may be fine to have lower efficiency, round trip efficiency, because you are only expecting to discharge the storage maybe 10 times or 20 times or maybe 50 times in a year. So from that point of view, maybe the lower capital cost and lower standby losses will be more important. But most of the applications right now we are seeing is a case where you are trying to use storage at least one cycle per day, or in many cases even 1.5 or 2 cycle per day. In such case, round trip efficiency becomes a very important parameter for making the overall economics work for storage as an application.
Thank you, sir. We have another question. Will grid defection be there in India? And if yes, when?
So again, this is a very interesting question, and I think internationally this is called as a utility death spiral. And I think we are a little bit far away from that point right now, but a lot of it will depend on how utilities react to this and how they start looking into power quality and reliability for customers, right? So, as probably most of you are aware, in India we have this tariff structure where agricultural and residential customer with less than 100 units pay the lowest tariff, and as you start consuming more than 300 units, for example in Pune, you are probably paying anywhere from 8 to 10 rupee for tariff, and if you are start consuming more than 500 units, you may be paying 11 12 rupees as a tariff, even as a residential customer. And if you're again commercial customer, then you are paying, including all your fixed cost and variable cost, easily 10 to 12 rupees per unit. So now these are the customers for whom using renewable energy and storage is already economical. So if you have space for rooftop solar, then adding storage to it and utilizing it more and using it for your evening peak is already economical. But still, right now, we feel that we have not yet reached a stage where people will completely go in an island mode, like what happens with large industries where they mainly use coal-based power plant, or maybe mixed combined heat and power kind of application for creating just a microgrid and get disconnected from the grid. I think looking at distributed renewables and storage, it may take another 10 years away. And right now, a lot of this will depend on what utilities are doing. For example, if utilities ignore the power quality and reliability concerns of customers, then right now what is happening is most of the commercial and industrial customers who afford already have storage on site in form of diesel generator, as well as in form of UPS systems for critical systems. As more and more power quality interruptions are there, people are looking at now, can we add rooftop solar or some captive solar and add more storage? And rather than using UPS system just for emergency backup, can we start using them every day and reduce reliance on the utility? So although we may not get a complete disconnection, but we may start seeing that many commercial industrial customers can actually cut down the requirement from the utility to almost half within next 2 years. Now that requires a lot more maturity and awareness amongst industries. Right now, unfortunately, we see this tendency that people think, oh, in 2 years, something is going to become still cheaper. So we should wait and watch. Whereas what is happening right now here is something is already economical for you to use. If you are going to wait 2 years for that deployment, that means in 2 years, you are probably going to pay a lot more money to the utility than what you would have invested into the technology right now. So we'll see how it goes, but we do see that there is a very strong possibility that the C&I customers can significantly reduce the total energy intake from the utility, but it may not be completely disadvantageous to utility, because while doing this, what we expect is that the C&I customers will start becoming more of a flat load for the discoms, where they can become like part of the base load. Because right now, one of the biggest challenge for discom is also the growing differences between peak and off peak power, where they have to keep on investing into transmission distribution upgrades, as well as sign up for peaking power, and not recover enough because their average tariffs are actually lower than the cost of the peaking power. So every time there is a difference in peak and off peak power, utilities are actually losing more money. And by maybe having some percentage of customers opting to reduce their peak load demand by using renewables and storage, may actually even help the utilities. So we are working with many utilities in trying to see, can even utility promote utility owned assets on the customer premises and then have a control on that. In US, we are managing a fleet of more than 100 Tesla Powerwalls for a utility called Green Mountain Utility in Vermont. And we have demonstrated that such partnership between utility and customers, and then active management of customer-sided storage by utilities, can be a good win-win for all the parties.
Yeah, thank you, sir. We have next question. We are using lithium-ion batteries in EVs. So are we using aluminum ion and aluminum air batteries?
Sure. So again, that's a good question. So metal air batteries are emerging, but they are still in early commercialization stage, and it may take still some time before they reach the manufacturing maturity. So again, many times we talk about TRL. So in terms of the technology readiness level, so I think especially aluminum air technology has reached, at least in case of one company, which is Finergy from Israel, which is a member of ISA. They have reached a TRL maturity of 9, and they are currently in an early customer deployment phase. But they still need to climb up the manufacturing maturity level, and how fast they do it will determine if these technologies get adopted. Right now, basically, these technologies may not be alternative to lithium-ion batteries, but they may be a alternative to lead acid batteries, where you can use them for backup applications. So basically, for telecom tower or some of the applications where regulatory wise they are mandated to have 20-hour or 40-hour kind of a backup in case of a disaster, they may be able to use lithium-ion batteries for short duration power outages, say less than 1 hour, and then use something like aluminum air as a cheaper, more energy dense technology, which can provide them that optional 20, 40 hour power backup, which they may not use more than 1 or 2 times in a year. So that way, it could be a good mix and match between metal air technologies and lithium ion or other advanced technologies.
Thank you, sir. Let's have the next question. I hope it is related to energy storage. A projected and lab proven conversion is claimed to be 47% at NREL in USA. Would you like to comment on this?
Sorry, can you repeat the question? I just briefly
Yeah, I
lost
think
the
so. It
sound.
is a question is written like a projected and lab proven conversion efficiency is claimed to be 47% at NREL in USA. It is. I hope it is related to energy storages or maybe batteries. Could you comment on this?
Yeah, can I just
Yeah, sure, sir, sir.
My point is that it is claimed to be the solar cells conversion efficiency, which is 47% by NREL. That is what is the claim I read. That's why I'm asking.
So typically 47 is quite high, so that may
Yeah,
be under some very niche technologies and other things. Typically, we are seeing basically when I started working on some of these large grid scale project back in 2007-8, the commercial solar cell efficiency was actually in single digit numbers. We
yeah.
are starting to start getting it closer to 20%. And we do expect that with some of the enhancement with sort of a both-sided solar cells and using also sort of some albedo enhancement techniques such as using white ground or having clothing and those are things it can increase. But I haven't yet seen anything which is expected to reach 47% in terms of the commercial grade products. It may be there in some experimental technologies.
Actually, they have claimed for
Yeah,
bifacial solar cells.
sure. Yeah, so with bifacial, then basically you have the both the sided, right? So then you are able to capture, and particularly if you couple it with the albedo enhancement techniques, such as using some specialty cloth to reflect more from the ground back into the backside of the solar panel, then you can start moving towards that. But there also, right now, commercially, I'm seeing numbers which are closer to 30%, but probably they have some next generation technologies which can possibly get to that. So that will lower the levelized cost of the solar energy further. And that's where there are many people or experts who are talking about getting solar energy down to 1 rupee. But still, it's going to still create the challenge where even if you get all the solar energy for 1 rupee just during maybe 6 to 8 hours during the day, what do you do for rest of the day, right? So that's where actually these type of enhancements will actually create more opportunities for solar and storage to work together and displace more fossil fuel energy sources.
Thank you, sir. We have next
Thank you,
question.
thank you, thank you, thank you.
How do you see a PQ problem, that's power quality problem, that would be created by renewables and energy storage themselves, as Indian market gets quickly populated by low cost devices where peak power quality goes for uh, toss?
Sure. So again, this is a very interesting question. It reminds me, I think, back in 2004, I had done a presentation on at one of the IEEE conferences in US on the issues related to harmonics and the flip side of it, where many times we tend to blame utilities for harmonics and power quality, but actually many of the harmonics or other power quality problems are now getting exaggerated by deployment of power electronics in every places, including now, especially now with the LED lights and everything. So anytime you're introducing a non-linear device, that creates a challenge with the power quality, and we have now power quality being fed back. So I don't think it is related only to solar and storage. I think we just have a lot of power electronics getting embedded into the distribution system everywhere, and that is going to create the problem. If it comes to solar and renewables, then actually it is relatively easy to solve, right? We just need to have proper standards and we need to have enforcement of the standards. I think in terms of technical standards, we already have standards which will address many of these known challenges. The question is, are we going to be just focusing on just the L1 criteria and just try to get the cheapest thing, or realize that power quality also ultimately has a cost? So as long as the customers start understanding that, and I think again IEEE can play a huge role in this. I know that Copper Alliance has been doing a lot of work on power quality and creating awareness on power quality with customers. But unfortunately, in India, what we see it is many times we end up actually referring to the power quality cost studies from US and other developed countries. But in India, we just have anecdotal evidence about what is the power quality cost. So again, if IEEE can take a leadership in doing some real study which can quantify the cost of the power quality or lack of power quality, then that would definitely help us in avoiding these type of issues.
Thank you, sir. We have next question. How can we address hydrogen transport and storage infrastructure requirements as well as environmental safety concerns?
So again, that's an excellent question. I think again, many times right now when we are talking about especially green hydrogen and its applications, storage is only considered more as a local thing. In terms of transportation, people have looked at various ways, including liquefying it or doing compressed thing or using different materials for sort of a chemically embed hydrogen into that and capture it, or the other form is using ammonia as a way for transportation. Now, different of these technologies have different pros and cons in terms of both capex as well as the operating costs. Like for example, ammonia is a very good way of transporting hydrogen, but converting ammonia back into hydrogen will be energy intensity wise not advisable. So if you can convert hydrogen into ammonia and then use ammonia for chemical processing or fertilizers or other related industries, then that's something which is very much viable. But if you need hydrogen in form of hydrogen, then probably you need to look at other technologies such as using materials or looking at liquefying that. But then that also you need specialty containers as well as the energy penalty related to liquefying and storing that in cryogenic temperatures can be substantial, and that adds as much as the cost of production of hydrogen on top of it. So a lot of the hydrogen adoption is going to be driven by regulatory requirement at least for next 10 years. And the key part there is to see how serious are the regulators. So right now we are seeing in Europe, this transition is happening almost naturally. And it is not because they have found out some miracle for reducing cost of hydrogen. But what has happened is with the increased cost of natural gas and petroleum devices, the cost of the SMR or the gray hydrogen has actually skyrocketed. So while most of the time we talk about green hydrogen as a goal of getting to $1, which was a price of gray hydrogen few years back, suddenly because of increase in natural gas prices, Europe is looking at gray hydrogen at $10. So they are ready to now consider green hydrogen, which is at even $5 or more for those applications. But storage and transportation is definitely a key challenge. We also need to start looking at safety. That is another big issue which needs to be handled for hydrogen storage and transportation. So right now, at least as IESA, we are focusing on primary applications where we think that you can actually transport renewable energy, generate the green hydrogen with electrolyzers at a site closer to where it is going to get utilized, and then maybe have some local dedicated pipelines to take it to the surrounding maybe multiple industries from that one single location. So that type of approach, I think for next 5 years, 7 years will make most sense. But then I think a lot of investments are happening into materials for improving storage, and we will see how that develops in next decade.
Thank you. So looking into interest of time, we have many questions in chat window. So let's have one or two. Sir, next question is, what is the state of battery repurposing in India?
Okay, that's a very good question. I didn't touch on that aspect in my presentation in interest of time, but second life is the common term being used for repurposing of battery, and it is mainly used in context of using automotive batteries into stationary life. There are some misconception on that, and there are some very good opportunities in that. So what most often get quoted is that when the automotive batteries are retired, typically they still have 80% of the capacity left. And although it is true, basically the capacity degradation curve for many of the batteries like lithium-ion batteries has a knee where beyond that 80% degradation, you may see rapid reduction. So in terms of the expected cycle life, say if you are reaching that 80% degradation in say 1000 or 2000 cycle, your remaining 80% degradation may happen within few hundred cycles. And that's a part where you need to be very careful that you don't end up dumping a lot of old automotive batteries and just try to sort of repurpose them and try to just sell them to customers who do not understand it. The other issue is that in terms of the automotive batteries, you need to be very careful in terms of how well the pack construction was, how well the battery management system was working, because you may have significant changes in the degradation within the battery pack. And you may have some cells where the internal resistance has increased substantially, some cells which are in good condition. If you have to dismantle the packs and reassemble it, then that ends up killing the economics. But if you have like maybe cylindrical packs, or if you have things where entire modules are good, then you may be able to use this for repurposing. Right now in India, already are seeing repurposing with like a old laptop batteries or other thing where people are taking out cells and then converting that into either battery banks or solar lanterns. So those are things unofficially are already happening. But again, if we have to take this into a real industry, then we need a more stringent standards and awareness to be created, because we don't want these second-hand life batteries to create a safety risk in case of there is a mismatch between the charger, and the charger does not understand that the voltage profile for second life batteries may be different than the fresh batteries. And also customers who are buying second life battery, it should not happen that they are thinking about, oh, they are just getting something at 20-30% discount. They need to also have a clear understanding that they may be getting only 10% or 20% of a life of a new thing. So you should be using the repurposed batteries for select applications where, for example, say a UPS or a backup application where you are expecting only 50 cycles or 100 cycles in a year, such second life batteries could be a very good application. But if you're looking at connecting the second life batteries to solar and use it for daily cycling, that may not be the best application, because within a year or 2 years, you'll have to replace it. So a lot of associated costs for installation, operation, maintenance, those will substantially increase. So it's very important to make sure that we create proper awareness and use these second life batteries for right applications before we send them for recycling.
Yeah, thank you, sir. Let's have last question. What are the main types of government subsidies and incentives available to manufacturers of energy storage and e-mobility technologies, and how do they differ across different regions and countries? And how can manufacturer avail them?
Sure. So again, different countries have clearly different ways. In some cases, there are capital subsidies available for setting up manufacturing. In some cases, there are incentives available based on the actual sale of products. So you have to manufacture and then demonstrate that you have manufactured that with certain local content. Like the PLI scheme falls into the second case where it is linked to doing domestic manufacturing and then demonstrating certain value addition. There are additional subsidies available from state governments, which may include a mix of capex as well as maybe GST refund or GST exemption, state GST exemption kind of subsidies. Again, as a ISA and CS, we are monitoring these very closely and helping many manufacturers in specific things. So again, if someone is interested, please reach out and we will be able to help you, because there are a lot of complexities you need to check in terms of not just the subsidy, but you also need to understand what is the cost of the land, what is the cost of the labor, what is the cost of electricity. Some states may offer certain incentives in form of cheaper electricity or some waiver on duties or taxes on electricity. Some may help by creating some common infrastructure such as the wastewater and treatment facility, which will reduce the capex for it. Some states are offering subsidies for training and skill development. So there are a number of different ways in which both state and central governments are trying to attract these investments, and you need to evaluate it in form of a complete financial for the facility. So it's not about just let's go to the state which is giving just maximum incentive. You need to look at it in form of a complete financial and P&L of the facility.
Thank you, sir, for giving
Sir,
what you can say.
only one small question related to our Pune section. Can I ask? Can I ask
Yes, sir,
Rahul?
go ahead. Yeah.
Can I ask Rahul?
Sure. Please go ahead, sir.
Sir, I must say personally, congratulate you of becoming senior member, IEEE senior member of Pune section. But it was on 24th of September 22. I just got your message. I saw your message. So only question is that you were given an opportunity to become a member of one of the new societies. So which society you are a member now other than PS?
So I'm also involved with the e-mobility section as well as the standard section
Okay.
for IEEE.
Okay. So you are a member of standard society, IEEE standards.
Yes.
Okay. So nice. Thank you. Thank you, sir.
Thank you, Rahul, sir, for clearing the doubts of many participants. There are a few more questions in chat window, but into the interest of time, we will not be able to take it. So I have taken some important questions out of it. So now I am here to propose vote of thanks. So on behalf of PESIS chapter, IEEE Pune section and Electrical Department, PVGS College of Engineering and Technology and GKPIM Pune, I am very much thankful to Dr. Rahul Walawalkar sir for delivering informative and visionary lecture for making India a global hub for R&D and manufacturing advanced energy technologies. Sir, you have covered various aspects about energy storages, policies, maybe Indian government policies, the cost aspects, different types of energy storages, India must start exercising. Thank you so much, sir, for your wonderful lecture. So as a token of our appreciation, we would like to present you the appreciation certificate, sir. Please, I hope the screen is visible.
Yeah, it
Thank
is.
you very much.
Yes.
So once again, I thank you, sir, for your wonderful lecture. I must thank here Professor Sachin Shelar, who was instrumental in getting approvals and sanctions regarding this lecture series from Tagare Madam and Tagare family. So I thank him for his genuine contribution in starting this DM Tagare Memorial Lecture Series. I thank all office bearers and Execom members and IEEE members for being present and gracing this event. I am thankful to IEI members for making it convenient to attend this online lecture. I thank all industry delegates, faculty members, and students from various institutions for attending this event and making this memorable one. Lastly, I thank PSIS group and SAM team for their wholehearted support for this event. And lastly, I thank Professor Abhijit Khurpe, for Secretary IEEE Pune section, for making this live on YouTube live channel. So I thank one and all who has directly and indirectly contributed for arranging this event. Now I declare this event is over. I request all the participants and panelists to turn on their cameras so we can have a good snap.
I'd like to thank both the Mandar sir and Surekha madam for actually pushing me for getting the senior membership. I think it was pending for more than a decade. But again, thank you very much for Surekha madam and both Mandar sirs for helping me in making that jump. So thank you.
Thank you. Thank you very much, Dr. Rahul,
Sir,
for this
thank you
particular
very
session
much.
and a continued engagement. We look forward for more such constructive engagements to benefit our members. Look forward.
Sir,
Thank you
we
very
would
much.
like to invite you for our Exicom committee also. It will be our proud privilege. I
So
will
no, happy to support whichever way.
invitation also.
Sure.
Thank you, sir.
Thank you.
And one more point from our side is like this year onwards, we would like to collaborate technically with IESA's flagship grand event that normally we do at Delhi. So we are looking forward to have a technical collaboration with a couple of your sessions at India Energy Storage Week at Delhi. We will do that.
So again, if
Sir,
there is interest, even we can start it this year itself. So particularly, we are doing a workshop on industry academic collaborations on first day, as well as on fourth. We are also doing a specially skill development roundtable. So particularly for both of those, I think you are already participating. But again, if officially, if we can have a more engagement with the IEEE community, I would love to do that. So we
Yes,
can
of course.
kickstart
We
with
are in
this, and then
connect
for
with-
next year we can plan it in a more active way. Also, for the
Yes.
World Energy Storage Day, also IEEE has been a supporting partner and would like to figure out if we can do something more to engage students from around the globe as part of that activity. So there again, if you think there is something which can be done, we can explore.
Sure. Anyways, and another, there are certain more opportunities. I would like to speak about them when we'll meet in person on 6th, on 4th, I think 6th. Yeah, 6th
Sure.
April, Rahul.
Yes, 6:30. Yes.
Okay.
So,
Thank you. Bye-bye.
thank you.
Thank you.
Thank you, everybody. Now,
Thank you. Bye.
closing this session.
Thank you.
Thank you.
Yes.
Yeah.
Yes.
Yeah.